Hello everyone, and thank you for joining me today. Our project is vegetation flammable characteristic as a wildfire. So this is today's agenda. We discuss about team and project. We discuss about project status, visualization, communication plan, recommendation given by team. Next slide, please. So this is a team. Jai Patel is a team leader. Then we have Rohan Patel, who work as a data analyst, Jamin Adhikari, developer, and me myself, Yash Ramani, as a data analyst. Next slide, please. So what is the project and who is client? Our client is Crowd Doing. Our goal is to tackle the increasing threat of wildfire by using data analytics and visualization. Specifically, we are focusing on the role of vegetation in wildfires and how we can use the data to better understand and prevent these disasters. So wildfire are growing global concern. The impact of that fire is devastating from loss of life and properties. But what if we could use the data to identify the areas at high risk of wildfire and take steps to prevent them? That's where projects come in. So what we do, we use data analytics and visualization to examine the characteristic of a different vegetation type in Canada by analyzing factors such as moisture content, density, ignition, temperature. We can identify pattern and clusters of vegetation that are more or less likely to ignite. We are also we are also creating certain heat maps to visualize the pattern and make them easier to understand. So what is a flammable characteristic? So flammable characteristic are like the uh, what makes some vegetation more flammable than others. So it is not just about the type of plant, but also the its state and the like it's decomposing, it's alive or it's dead. By understanding this kind of flammable qualities, we can better predict the how wildfire will behave and take steps to prevent them. Our research is shedding new lights on the complex connection between plant and fire, and using how we can use this knowledge to mitigate wildfire risk. So what does it mean for wildfire prevention and management? By identifying areas at high risk of wildfires, we can target our efforts and resources more effectively. We can use this information to develop more effective strategies for preventing and controlling wildfires. Next slide, please. So this is the project timeline for our. This is timeline for our project. From project, it started from July 24 and ended at November 24. So for first 3 weeks, we've been focused on gathering data and conducting research for our project. We explored a range of articles on wildfires and impact of vegetation, and we searched through website to locate the most relevant data set for our analysis. This research will provide us a strong foundation for moving forward with our project. Next slide, please. From now on, my teammate Jai will take over.
Thank you, Yash. After finding the data set, we have moved further for the exploratory data analysis, and for that we have started on the analyzing the data sets. For example, we have analyzed all the columns and what they mean. Then we have gathered all the information about each and every column from the article that we have for the reference article from we have found the data set. So we have done pretty good job on that because we have 72 columns, so we have to analyze that what are the columns that we can use in this project, and which are the column which are removable. So after that we have directly jumped to the pre-processing for the accuracy of the data. So we have started with removing the null values, then we have removed the duplicates so we cannot repeat any values. Also, for removing the null values is also important because if we remove the null values, then we have better accuracy in analysis. Then we have handled the missing value with some mean and mode that we will see in further slides. So this is our data set. This has 72 columns and more than 555 rows. Then we have moved to the week 6 where we have moved further in the exploratory data analysis. So in this week we have done univariate analysis for each and every variable. We have done a frequency distribution using the Python, and we have handled some of the outliers. So for univariate analysis, I have started with the pandas library, importing the pandas library in the So for the univariate analysis, I've imported the CSV in the Jupyter notebook with the pandas library, and then I have just shown the data. I have just shown the data frame, which has the five rows and 35 columns, because this returns only that much. Then I've done some univariate analysis for the categorical variables and the numerical variables. Then I've just printed it. So these are some of example for the categorical and numerical variable, univariate analysis of the categorical and numerical variable. Then, for example, univariate analysis contains the mean, median, mode, and standard deviation, minimum, maximum things like that. Then this is the frequency distribution for all of the variable. Frequency distribution, we have done frequency distribution for like getting to know that how the variables are distributed. For example, the northwest has a more than 140, for the one more than 140 data has a northwest, and less than 40 data has a south direction. Then we have 5 species in our data set. So this is for the one species. This is all of them are more than 60, but the populous one is more than 70. So we can get to know that by doing the frequency distribution. We have 3 types of soil texture in here, like that. So we have done this using the Python in the Jupyter notebook. So firstly, I've imported the CSV to the Jupyter notebook, and then I've just shown the distribution for all. So I've done it for all the variables that we are going to use. For example, the count, this has a 32 columns, 332 different observation. The mean is 51.84. The standard deviation is 63. The minimum value is 24, and the maximum value is 430. So that's how we can do the univariate analysis for each and every variable. And for the standard deviation, as we can see, that we have a like 2 type of burn treatment, dry and wet, something like that. And this is for all the variables we are going to use. Now further is up to Jaimin.
Thank you, Jay. So this is the pre-processing part of the data set. So here I have tried to pre-process the data. So on the very first, we have started with the importing the data set. Then I have visualized the all columns from the data set to better understand the data set, which columns we need and which columns we don't need for the further analysis. That can be evaluated by the viewing all the columns name. Then I have print the all unique values from the data set, so which can give us some knowledge about the data set, that which columns we need for the particular analysis. Then I have tried to print the null values from each and every columns. So here we can see that there is no null value. So every column has a 0 null values from the data set. Then we drop the duplicates column from our data set to avoid the major false output. Then we have renamed the column. So aspect become the terrain aspect, same as the average sand become the average soil sand percentage, same with the clay, and wedge type is become the vegetation type. So that is how the rename can be helped to identify the particular column with their characteristics. So it is easily recognized by the data analyst to analyze the data. Then I have dropped the column that is irrelevant from our data set. So the very first column is the year. So in this column, every record has a 2019 value. So this is not useful for our further analysis. So we have decided to drop this column. Same with the change in carbon and neutral ratio, which is also can be depicted with the changes per time, but all the records have the same year. So that is why we have decided to remove that column as well, because we no need for that record for further analysis. So that is how we decided to each and every column that which column we need and which column we doesn't. Then we have executed all the renames and dropping the unnecessary column, and then we save our updated data set. Then after I try to visualize the box plot for the main key values for the low temperature hours and mid temperature hours. Same with the moisture index 1 and 2. So here we can see that we have some of the outliers in our data set. And then the pairwise scatter plot can depict the interdependency from the variables in our data set. So here we can see that there's a low temperature hour and same with the high mid temperature hours with the moisture index 1 and 2, same with the horizontal side. So it can depict the interdependency from the particular column. Then we have manually created the violin like plot chart. This is the histogram chart which shows the density of low temperature hours and mid temperature hours, so which is a distribution of data that can be visualized as a identify the outliers. Then we have identify our outlier from our data set by the IQR technique, which is very useful to identify outliers by the quantile rate. Then we have changed the replace the outlier value with the mean value. So every lower bound and upper bound value from the column can be replaced with the mean value. So that is how we handle the outliers from our data set without removing that value from our data set. Then we compare each values with the box plot and the histogram comparison. So here we can see that this box plot comparison for average soil sand percentage. So there are some of the outliers, which is upper and lower bound as well. And in the handled data set, we have no upper and lower bound, which shows that we have replaced the values with the our mean values. Same with the histogram comparison. So blue part can shows the original values from our data set, and the saffron part will show the handled values. So we have tried to plot the every single, not every single, but the most major of the columns for the better visualization. So here we can see that many of the column has the outliers, and how can we handle that outliers is also seen in a histogram comparison chart. So next part will be covered by my friend Rohan. Thank you.
Thank you, Jamin. In this project, we use the variety of the tools to handle the different aspects of the data analysis and the communication process. We used the Jupyter notebook for the programming in Python, which was the essential for the processing and the cleaning our data. And next, the Power BI was used to generate the comprehensive visualization that could clearly communicate our finding things. This tool enable us to create the various charts and graphs to present the data in a way that easy to understand. Similarly, we will use the Tableau to create the heat map because it is more convenient as compared to the Power BI. For team communication, we rely on the MS Teams and the Google Meet, which ensure the smooth collaboration throughout the projects. Next slide. In this slide, in terms of hours, we initially the budgeted the 20 hours for the requirements phase, but ended up using only 18. Similarly, for the design, we budgeted 135 hours, and we completed that works in 118 hours. This demonstrates our team's ability to work efficiently, and they deliver result on the time. In terms of cost, the budget for requirements was $1,000, and we finished under the budget $900. For design, our budget is $6,750, and we completed the phase with actual cost of $5,900. Overall, we successful manage both time and resources. Next slide. We faced some number of challenges. One of our primary challenge was the risk of the overfitting when they removing outliers. Outlier removal is a sensitive process. If not done properly, it can be distort the data. To avoid this, we decided to gain domain knowledge to better understanding whether the certain outlier were significant or could be replaced with more reasonable values. Another challenge was to choosing the right machine learning model for our analysis. Nowadays, so many models are available. We are not initially sure which would provide the best result. So to address this, we conduct the research on the various models and assess their suitability for our specific data set. There was some confusion about the visualization tool to use between Power BI and Tableau. Both has straight, but after some research, we determined the Tableau was the best choice for the creating heat maps, and for more visualization, Power BI is good choice. Next slide. As we worked throughout the project, we identified a few key recommendation for the improvement. Firstly, we believe that the weekly client meeting would be more beneficial than the bi-weekly meeting. More frequent communication would allow or faster feedback and course correction, ensuring that we stay aligned with the client expectations or not. As I discussed earlier, we also using the table view as the go-to tool for our heat maps. Its features make it the best choice for creating detailed and interactive visualization. And lastly, we suggest creating the data pipeline for live data. This would allow for continuous our data updates. Next slide. Thank you.